Hi, today's lesson is on direct variation and a little bit on indirect variation. So, we are going to start with what is direct variation. And we use the equation y equals ax to represent it. And it means as y is set to vary directly with x, x increases or decreases. What it means in English is if x increases, y increases. Or if x decreases, y decreases. They do it together. So they're in conjunction. Some real life examples of this are if you work more hours, you make more money. If the cost of gas goes up, it costs more to fill your gas tank. They both change together at the same time. What we do have is a non-zero constant, and we use a for that, and that is called the constant of variation. In most equations, if you look at the way these look right back up here, y equals ax, a is the slope. It acts just like the slope. However, there is one big difference in these. There is no y-intercept. So for it to be direct variation, it must go through the origin. So that's your big visual clue right there. So it is a line with the slope of a, and a is the constant of variation, and a y-intercept of 0. All these lines that you see right here, those are all direct variation. It can be positive or negative, just depending on what a is. Okay, so to solve for a, or to solve for the slope, the constant of variation, you use this formula y equals ax. And it's simple, and I'm moving the screen around, be still. And I don't think you're going to have any trouble with it. So your questions look like this. Write and graph a direct variation equation that has negative 4, 8 as a solution. So to do that, you know what the answer is. You have to work backwards. So think about what you're given. You know x and you know y. So plug them in. Put them into your equation. So 8 equals a times negative 4. You have to solve for a. That's mostly what we're going to be doing on these, is solving for a. So a is negative 2. However, this is the gotcha. You are not finished yet. You just found a. You have to write an equation. To write the equation, you do this step right here. Substitute negative 2 in for a. So put in what you found back into the formula, and we're going to get this equation right there. That's your direct variation equation. Don't stop too soon. It's very simple, very straightforward, nothing tricky. There's another way you can look at it. If y equals ax, what does a equal? So we're going to solve for a. So that means we divide both sides by y, or I'm sorry, both sides by x. So a equals y over x. And if you know that, you can solve for a immediately. We could put these numbers in right here and get a equals 8 over negative 4, which is negative 2, and we plug that right in. So we just talked about direct variation. We also have inverse variation and joint variation. So direct, we said, looks like y equals a times x, or as x gets bigger, y gets bigger. Inverse is just the opposite. It means as a gets bigger, y gets smaller. Or they move in opposite directions. So the more you exercise, the more calories you burn would be direct. But let's see of one that would be inverse. So the more you exercise, the less you weigh. That's inverse. Its formula looks like this. Y equals a over x. A cannot be 0. It's set up almost exactly like direct. So to determine if equation shows direct variation, inverse variation, or neither, you solve for y. So that's what we're going to do. We have two formulas. This is direct, and this is inverse. So if you're trying to figure out if your equation works, solve it for y. So an inverse variation equation is going to look like y equals a number over x, Or, and they'll get you with this, sometimes it's something like that, okay? Now, direct variation looks like a number times x. And when you see something like what I just wrote, that goes right here because you're multiplying something by x. What they're going to do is show you this, and you'll get confused. This is where you divide by x. It's on the bottom. That's inverse. Generally what's going to happen with neither is you're going to have an intercept at the end. You're adding or subtracting something to y. You can't do that. So if you're adding or subtracting something to y, it's neither. Otherwise, it's going to look like something divided by x or something times x. Now, to write these equations, it's pretty simple. You'll generally be told that the variables x and y vary directly or inversely, and that's the formula you're going to use. So in this case, we said they vary inversely. Okay, my pen's not writing. There we go. So it's going to vary inversely, and we know what x and y are. It says then write an equation that relates x and y, so that's the second part, and then find y. That's the third part. Don't stop too soon. So the first thing you want to do is it's inverse variation. There's our equation. Y equals a over x. Now we're going to substitute what we know in, so plug in for x and y, and then solve for a. So now we've done the first little bit. We found a. And on inverse variation equations, here's a hint. If your original formula is y equals a over x, that means a equals x times y. So if you think about it, a equals 4 times 7, a equals 28. This way is pretty fast. All right. Now that we know a, we're going to go on to step 2, and we're going to plug it in. So instead of an a, we're going to put in 28. So y equals 28 over x. Now we're rocking. Down to your third part. Find y when x equals negative 2. Well, plug in x and see what y equals. So these are really straightforward. Don't let the wording scare you. So let's do one of these examples together. All right, we're going to do this first example real quickly. We will do a lot more examples in class. We'll fill out our notebook. Don't worry about it. So if x equals 4 and y equals 3, it says we're going to write an inverse variation equation. So because I just found out, I know that x times y equals a. So a equals 4 times 3, which is 12, or you could use your formula, y equals a over x, so that gives us 3 equals a over 4, which would be 12. So we have those two. Now we're going to plug it into our formula, so y equals a over x gives us y equals, what was my a? 12. 12 over x is y. Now, if I wanted to find an answer from that point, I would just plug in.